Welcome back to the deep dive. If you've ever had to run a high-resolution video cable through, a crowded server room or up through a ceiling, you know the nightmare.
Oh, yeah.
The signal starts to degrade, the cable is impossible to bend, or you end up needing a power adapter in the worst possible spot.
Exactly. Copper just has a hard limit on range.
So today we're looking at that exact problem. How do you push something like 8K video over really long distances without compromising on quality or making the installation a complete headache?
And our mission is to unpack one specific solution for that, the DVIGear DVI-2820-AOC. It's a DisplayPort 1.4 active optical cable. We're going to look at how its mix of fiber and copper works.
And crucially, why its physical design might actually be the most important feature for the people installing it.
I think so, yeah.
Okay, so if that hybrid construction is the key, let's start with the speed. How does it handle DisplayPort 1.4? We're looking at HPR3 compliance.
Right, which, in simple terms, means it has a massive data pipe, an aggregate data rate of 32.4 gigabit per second.
So 8.1 gigs per lane.
Exactly, and that kind of bandwidth is what lets you do some really impressive things.
Like 8K video?
Like 8K at 30 hertz with full, deep 24-bit color. But maybe more practical for a lot of professional uses today is flawless 4K at 120 hertz.
And here's the kicker. It does all of that not over, a 15-foot cable you'd buy at a store, but over lengths up to 100 meters.
328 feet. That's the length of a football field.
It's the difference between a desk setup and connecting rooms on opposite sides of a building.
And that range is only possible because of that hybrid build you mentioned. It uses 4 strands of glass optical fiber for the actual high-speed video data.
And the copper.
The copper's still there, 6 wires, I believe, but it's just for lower speed stuff, power and control signals.
Okay, so this is a huge deal for anyone who's actually had to pull cable before. It says here it's plenum rated.
So it's safe for air handling spaces. That's a big compliance checkbox for commercial installs.
But also, it has a minimum bend radius of just 35 millimeters. That's incredibly flexible.
It is. You're not fighting the cable. You can make those tight turns inside a wall or a conduit without worrying about breaking something. It just makes the whole process simpler.
And they seem to have carried that focus on installation right to the connectors.
They did. This is really clever. The cable itself terminates in these tiny mini DisplayPort connectors. They're less than 8 by 11 millimeters.
So they're super easy to pull through tight spaces.
Precisely. Then, once it's pulled, you attach these detachable, full-size DisplayPort connectors that have locking pins. So you get security and broad compatibility.
But what about durability? I mean, when I hear fiber optic, I sometimes think fragile. Is it as tough as a big, thick copper run?
You'd think that might be an issue, but the specs say otherwise. For what they call mission-critical applications, they rate the mean time between failures, the MTBF, at over 150,000 hours.
Wow. That's, 17 years of continuous operation?
Basically, yeah. It's built to last.
And another thing I love here, no external power brook.
No, that's another win for cleaning stalls. It draws all the power it needs, which is tiny, less than half a watt straight from the DisplayPort source.
That focus on reliability seems to extend to signal security too.
Well, because the main signal is light traveling down a fiber, it has a very low RF EMI profile.
Meaning it's not susceptible to electrical noise from other equipment, and it's not leaking its own signal out.
Exactly. So for sensitive or secure environments, that's a huge deal. Plus, the whole thing is TAA compliant.
Right, so it meets U.S. government procurement standards. And just to confirm, it still handles all the necessary control protocols. EDA, HTCP.
Yep, that's what some of those copper wires are for. It fully supports bidirectional comms over the AUX channel, so your source and display can talk to each other just fine.
So when you boil it all down, the value proposition is pretty clear. You're getting extreme bandwidth.
32.4 gigs.
Over an extreme distance.
500 meters.
All in a package that's reliable, secure, and actually easy to install.
Right. So that leads me to a final thought for you to chew on. We know professional setups now need that flawless 4K 120 hertz or 8K signal over these huge distances. But consider all those features at once. That tight 35 millimeter bend radius, the immunity to electronic noise, and the TAA compliance. What very specific, high security, tightly packed infrastructure challenge is a product like this built to solve almost stealthily? That's something to mull over.